Hello and welcome everyone to another session in the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Siddharth, part of the data science team at Analytics Vidhya. So, for those who have joined us for the very first time, a brief introduction to the DataHour sessions. Guys, the DataHour is a series of webinars conducted by Analytics Vidhya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding for our community members. So, now on to our session for today, which is practical applications of data science in e-commerce. So in this data, Anurag is going to demonstrate the use cases that leverage data science frameworks for driving higher revenue through improved personalization and demand discovery. So guys, before we kick things off and I hand it over to our speaker, a quick recap of the housekeeping items. We are recording the session and we'll make the recording available in a few days on our YouTube channel. And please use the Q&A section for asking any questions you might have during the session. And we will do our best to answer them as the data progresses or towards the end. And also we will share a poll about the feedback of the session towards the end of the session, which I request you all to kindly fill up. So now guys, on to our speaker in this session of data, we have Anurag Nair with us. So guys, Anurag has more than 7 years of experience in data and analytics domain. He is currently working as analytics manager at Myntra. He is responsible for facilitating data-driven executive decisions across various verticals. And previously, he has worked with Genpact and Mu Sigma as a data scientist. So guys, so now over to you, Anurag. The virtual stage is all yours. You can share your screen now.
Thanks for the introduction.
Yeah.
Hello everyone, thank you for joining. Good evening. I'll quickly share my screen. Is my screen visible?
Yeah, it's visible.
Okay, so yeah, I think I'll quickly start. As Siddharth mentioned, I think I have about 7 years of experience in this domain, and currently I'm leading the revenue analytics team at Myntra. So today, what we'll be talking about is a couple of use cases I have brought, and maybe we can discuss more. But two very simple but underused use cases of data science applications, which e-commerce companies often use. So there are various different e-commerce companies in India like Myntra, Flipkart, Amazon, right? So a lot of you would be familiar. Many of you may have even purchased from them. So some of you might be able to relate to how it all works behind the scenes. So I'll quickly start. So the first use case that I wanted to discuss was personalization through brand preference, right? And so what do I mean by that? So a lot of us don't fail to realize, especially while working with data, is customers make decisions psychologically and not based on a particular pattern. So one example I could give you is 20 years back, most of the groceries that were bought across, let's say, tier 2, tier 3 cities were through essentially kirana shops or local grocery shops. And that's because a lot of the families had personal connections with these grocery shop owners, right? They used to they used to lend money, they used to keep record of all of the transactions you make with them. And so there was a personal connection there. How it has evolved right now is you have everything or most consumer items in metro tier 1 tier 2 cities being purchased online, right? And in this scenario, how do you build that kind of a personal relationship with the customer? So one way is through brands. So a lot of brands that exist across various categories, take phones, footwear, clothing, apparel, which Myntra specializes in, or beauty, which again is available on Myntra and Nykaa. So a lot of these categories now have various brands who have built a certain image through the quality of product they sell, through their price range, various different factors on these e-commerce platforms, right? So think of the e-commerce platform as a marketplace, right? Where a lot of different brands are essentially either competing against or are unrelated to other category brands, right? So one way to build a relationship with a customer is to often recommend them, and seems simple, but it's to often recommend them the brands that they are most likely to purchase. Now, this may be brands that they've already purchased in the past. So one example would be if you've bought, let's say, footwear from Campus, or if you bought footwear from Nike, right? You may not have bought from Puma, but intuitively we know that Puma also applies to them. They're the same target market. It's the same category, sports footwear, right? So a lot of these signals tell us that customers have a relationship with brands, but then there are certain other brands that they also qualify for, but don't get enough visibility or are not inside their current price range, right? So how one of the ways we go about personalizing is, so if you look at the first box here, the first question is which brands we often purchase, right? It's a very simple thing. So if we look at customer data, and uh, I created these so that we can visualize it, but you can also think of it in terms of data. So if you have for each customer one row with a set of all the brands that they've mostly purchased, they often purchase, they've recently purchased, right? So for each customer, you would get a set of brands. For example, customer A here likes to buy Nivea and Lakme from, let's say, an e-commerce store called X, right? And customer B buys Himalaya VLCC. Seems like personal care, right? Personal hygiene products or personal care products, right? This also is borderline, I would say, beauty and cosmetics. And customer C, let's say, buys Nike and Puma, so they're into footwear, right? So customers have an affinity to certain brands in various categories. So often when you go to supermarkets, when you look at shampoos and are deciding which one to buy, the only things available there are the packaging, the placement, and whether you are familiar with the brand or not. So, say popular shampoo brands like Pantene or Sunsilk have sold a lot throughout the years because these CPG brands essentially have gained good enough shelf space. They often stock up and they keep coming up with new packaging to entice customers to continue their relationship with them, right? And so what we do is first we try to understand which brands our customers are fine to, right? So if customer A often purchases Nivea, Lakme, say L'Oreal, say Huda Beauty, right? There's various different brands. And so we get a list of all of these customers and the brands that they are affine to, right? Similarly, the other question comes, which brands are often purchased in the same basket, right? And so what we're trying to find out here is, let's say you are at a supermarket, and I give this analogy because it's very similar to e-commerce, it just happens online. So let's say you're at a supermarket and you have a cart with you, and you are trying to uh, decide on which products you want to buy in this particular visit of yours, right? And so there, if you think about it through customer transaction data, right? For each transaction, we as a e-commerce company already know which brands they have purchased within that particular transaction. And that's what's often referred to as a basket, right? So for example, if you went to a supermarket and let's say you bought oil from Parachute, you bought, let's say milk from Nandini, right? And you bought, let's say, a shampoo from Himalaya, right? So these brands now have occurred together in the same basket because you bought all of them in your same visit, right? Something similar can be done across all different customers who visit an e-commerce platform, right? So for each customer, you would have all the transactions that they made, and then for each transaction, you would have which are the brands that they've purchased, right? And I have another slide on going slightly deeper on how we get this to happen. But let's say if there were a method that could help us bucket these brands together, right? For example, customers who buy Puma are also likely to buy something from Puma. Now, Puma, for example, sells footwear, sells sportswear, right? All kinds of different uh, categories exist. And so, let's say if a customer who buys something from Puma often buys something from Fila also, and uh, also we've observed that they buy a lot from L'Oreal, right? And this could be gender separate also, but I've taken a common use case here. Similarly, if you see here, there's a basket where Adidas occurred, Under Armour, and Nivea, right? And so what we try to do is create baskets of brands, right? So baskets of brands that occur together, right? And so if we know a set of brands often occur together, if I direct a customer towards two of those brands which they like, then the three other brands in that basket are also likely to be discovered by the customer, which they end up liking more, right? It also helps increase brand penetration for the e-commerce company. So you want your customers to try various different brands of products and then choose what they like versus go with one brand, because they are at a high risk of churn if they only purchase one sort of thing from your platform, right? So, for example, if I always buy cosmetics from Nika, right? If the same cosmetics are sold at three other e-commerce stores, right, and the price is the only thing that creates the difference among them, then it eventually this company gets outcompeted by smaller players who give larger discounts, right? And so what we try to do is we try to create baskets of brands that we will map customers to, right? And so the third step is that. So these customers ABC, based on their set of brands, and I've only included few examples for each, but you could have 3, 4, 10 brands that the customer often buys, right? If you've bought 25 brands till now, you could easily have a top 5, top 6 brands that you often buy. And so those customers are now mapped to one of these baskets, right? And so, for example, customer A is mapped to say a basket S. Now, this basket S could be this basket, right? And so these brands, along with various others, so let's say there could be 8 to 10 brands in a basket, right? Now, how do I do the mapping? So that could be done in various different ways. Obviously, we follow a particular way of doing it whenever we do this at Myntra, but even for other companies, I think it depends solely on the use case. So, for example, if a basket has 10 brands and you are affine to four of those brands, that could be a high affinity score, right? Whereas someone else is only affine to one brand there. And so we there are various similarity measures, but essentially what we do is we map customers to these baskets, right? And that is because if you are someone who buys a lot of Adidas, right? We believe through the data, and I'll show you how we get the association rules. But uh, through the data, you have observed that these guys are also likely to buy something from Under Armour. They might also buy something from Nivea, right? And so we are trying to increase brand penetration through through these exercises, right? Now, this section in between, so the first section is pretty much clear, but in the second section, how do we create these baskets of brands, right? So, which combinations exist? Which one should we go for? So, the simplest way in going about doing that is association rule mining, right? And the most popular algorithm is a priori algorithm. Now, there are various other methodologies that I haven't included here. For example, you could do collaborative filtering to understand which customer should be recommended which particular brand, right? And so Netflix, the famous Netflix case of when they first came up with the recommendation engine, that one ended up using collaborative filtering, right? The reason why I've included a priori algorithm here is because this is the most practical use case that you can take advantage of at a store. So if I want to recommend a different brand to each and every different customer at all the time, it's very hard because the store is fixed. You have a finite amount of real estate where the customer views various different products and chooses one from them if they have an intent to buy. And so it's very hard to pop up brands in the customer's feed, uh, which often also disrupts their flow of browsing, right? So the reason why we do this is you can always recommend brands in cohorts, right? So you may have seen banners on, let's say, Amazon saying buy let's say sportswear, right, from XYZ brands, right? And so those combinations of brands, what they're essentially doing is filtering or putting a default filter in the backend of a category selection. So all the stuff that belongs to brand XYZ gets filtered for you. And so you only observe those brands, right? Instead of just one brand, right? And so this is just a very simple use case of how you would go about doing it. But you can definitely Google, there are a bunch of tutorials on this, and you may find them on YouTube and Google also. But how what it would look like is essentially this is what the input data would look like, right? It's transaction data. So each row is one customer here, and what you have here is the item that they bought from that store during that visit. So this is just an example. You could have a number of items here, right? A supermarket, if you already observed, has a bunch of different items. So you will have about 100 to 150 columns here, just because there are a large number of distinct items that are sold on pretty much any e-commerce platform. So uh, this is sort of what the input data looks like. Now, what the a priori algorithm gives you, and you can read about this, but what it essentially gives you is what is the impact that one object has on the sale of the other along with it, right? So one example would be, let's say you've gone to the supermarket and you've bought uh, bread, right? And you've also bought butter. Now you keep going to the market every week, let's say, right, for shopping. And what we observe is every time you buy bread, you also buy butter, right? So so the question arises, should I recommend butter to someone who's already buying bread? Not it's not clear, right? Why? Because butter could be purchased individually also. Maybe you just have butter with everything, right? And so the bread has pretty much nothing to do with it. So association rule mining essentially filters out rules that you can use to identify which products drive higher sales of other products, right? And the reason why we do that is we can obviously bundle them together, create packages that we can sell at a discount, or we could provide recommendations on, you may also like, as is already mentioned, you may have seen on Amazon, people also purchased, and then you get a bunch of recommendations, right? So those are some potential applications for this. So how the output here is interpreted is based on a particular item, let's say curd. What is the impact of the sale of yogurt and whole milk on curd? So the moment I added curd to my basket, how likely am I to also add yogurt and whole milk to my basket, right? If I'm very likely, and if it's the best recommendation for curd, then that's what should show up in your you may also purchase or you may also want to purchase, right? So we are essentially trying to find what input should go into the recommendation, right? So this is not necessarily the best way to recommend for an e-commerce platform, but it often helps with running campaigns, right? You may want to run certain campaigns and recommend customers based on their last purchase, right? Or something they've purchased last 2 or 3 times or very recently. So this has a bunch of use cases there. So if you see the input here, what is the impact of curd on yogurt and whole milk? There are various metrics you get here. So in this image, you see support and lift. There's also something called confidence. So what are these? These are basically ways of measuring how strong a particular rule is, right? So if someone tells me, hey, if someone's bought a t-shirt, I should recommend them jeans, right? But that is completely intuitive and at the moment hypothetical. You would have to look at the data to identify how that works out. And so that's what the a priori algorithm is used for. The interpretation here would be, if I purchase a brand X, how likely am I to purchase the brand Y, right? Based on the use case that we saw. So uh, the support here would tell you, okay, how often do both of these occur in among all transactions. So n here is the total number of transactions that you have in your complete data set, right? And then X is a particular brand and Y is a particular brand, and you want to understand how often do they occur or what percentage of times do they occur among all my transactions, right? So why we look at support is we want to understand, okay, if certain brands don't occur together very often, they have a very low support essentially, then there is no, we are not very interested in combining them together, right? So that's why we use support as a measure, and we put cutoffs. So for example, you could have 0.015 as the cutoff here, right? And so that cutoff would help you identify, okay, which items or pairs of items have now qualified for a rule set, right? So that's support. uh, we also look at confidence. So what confidence is, if you see here, an FRQ stands for frequency, if it's not clear. But yeah, basically frequency of brand X and Y occurring together divided by just the frequency of brand X occurring. So for example, uh, if I'm looking at the impact of the sales of, let's say, Nike on Puma, right? So how often does Nike and Puma occur in my transactions divided by how often does Nike occur individually, right? And so the reason why we do this is because we want to try and eliminate the effect of the individual effect of Puma, right? You may just like Puma as a brand, and that is why you're buying it. It so happens that you also bought Nike within the same purchase, but they may not have any relationship with each other. Right? And so confidence is a metric that helps us determine that. So finally, the key metric that we use to eventually identify what should be recommended for each brand is lift, right? And so lift is basically a support by confidence, essentially. So uh, this is basically like a use case where you can recommend certain brands to certain customers. So if you think about the homepage of Flipkart, right? You have a top banner there, right, on your homepage. And so if you see buy sports, let's say buy activewear, right, from Nike, Puma, Fila, and so on, right? Yeah. Uh, yeah, Tangamani, I think you uh, had a question.
Yeah, we can take the questions at the end if you
At the
want.
end. Great, great. Yeah, I'll leave 10 minutes at the end
Yeah.
for Q&A. Yeah, works. So yeah, I think yeah, coming back, the idea here is basically bundling brands together and then running campaigns for those brands. So if I go back to my previous use case, let's say Adidas, Under Armour, and Nivea are brands that often occur together. What you would see companies do is they would have a banner that, let's say, a creative team creates. They would have certain copy. So for example, uh, take a look at these styles that we've specially curated for you, right? They would have something like that, and then they would have the logos of these brands because people often relate to these logos, right? And so you could obviously add discounts, let's say 10% off on purchase of 1,000, right? Something like that. And so that incentivizes customers to explore other brands similar to what they've already purchased or trusted, right? And so it helps improve brand penetration. It gives you recommendations based on brands that you're most likely to purchase, right? And it also helps increase the size of the basket. So if you purchase one of these items, let's say you bought shoes from Adidas, right? And then you saw I have a tracksuit from Under Armour that's good. You want them to make the purchase within the same transaction. You don't want them to come back because the likelihood of transaction goes down, right? So that's the general idea. Okay. Yeah. So I think that's basically the main use case here. It's brand personalization and essentially penetration among certain cohorts of customers. Yeah. So demand discovery. Okay. So this is the second use case I wanted to discuss. So one of the things that you would have observed with various e-commerce firms over the years is every firm starts with one particular category, right? For example, there are, if you look at what Myntra did, right? Um, Myntra started primarily with apparel for many years, and then they slowly started adding various different categories. First, they started adding, let's say, footwear. Then they started adding, let's say, sportswear, and then they went outside their core categories and, let's say, added beauty and personal care, which is also a very large category there. So there's also kids wear there. So there's every e-commerce company, Amazon, Flipkart, Myntra, Nykaa, all these companies eventually end up expanding into various different categories, right? The problem that companies often face is, let's say you are a site that is primarily focused on selling kids apparel, right? You sell kids clothing. Now you've started cosmetics. They often don't go together, right? So what do you sell along with it? So let's say if you are a footwear store and then beauty and personal care has more alignment with it, and you decide, okay, I will start a beauty business also. I'll add a selection of products, and then we see how it goes, right? What ends up happening is 95% of your revenue would still come from footwear because that's what customers associate with. right? But they do spend on beauty and personal care products, let's say, but on other platforms, not necessarily yours, right? And so, how do you get them to come to your platform, trust your platform for these products, and then start purchasing them from here? So, let's say if you're someone who buys cosmetics or lipsticks a lot, let's say, we'll take an example, and you've never bought lipsticks from Flipkart, right? You've only bought, let's say, footwear and apparel from Flipkart. So, Flipkart would want you to explore their beauty collection and then end up making those purchases here rather than at some competitor's site, right? And so demand discovery is essentially around finding demand in customers that is being satisfied elsewhere, right? At other e-commerce sites or through offline forms. So how we go about doing that is, so one example I could give you is, let's say you are starting a new category. Let's say I want to start selling um, let's say I want to start selling consumer electronics, right? So if some of you may have observed, if you are a regular user of Swiggy, maybe you might have observed that Swiggy has started something called Minis, right? Where they sell headphones and AirPods, various other consumer electronics, right? But Swiggy is primarily a food platform, right? You would not expect someone to buy consumer electronics. So they slowly started with Instamart, which delivered groceries, delivered various other CPG products, and then eventually they've now expanded into electronics. So when they start selling electronics, people are not going to look at, let's say, which headphones you want to sell because you're not a platform that primarily sells headphones, right? So how do you find customers who are likely to buy headphones from your website, so or your app? So one way is purchase propensity, right? So purchase propensity, and this again occurs in various different forms in data science, but propensity essentially means finding customers and their likelihood to purchase some things from your platform. So if I am Flipkart and I start selling laptops right after I start selling phones, right? So I've been selling phones for a year. Now I'm starting laptops, and it's been 3 or 4 months, and the laptop sales haven't gone up, right? Why? Because people are purchasing them elsewhere. So how do I find customers who are likely to who trust the platform enough, who made enough purchases? Could be various factors, but who are basically ready to trust and are most likely to purchase from your platform if you incentivize them, right? And so one of the ways is a purchase propensity model. So how this model essentially works is we basically look at all the different factors that have an impact on a customer making a purchase, right? So what are the things that have an impact on purchase, right? If you look at the customer's history, right, you can always say that, okay, if a customer purchases every month from a particular store, they are likely to come back next month also, right? If a customer spends at least 1,000 rupees in each of their transactions, they are likely to spend at least 1,000 in their next. Now, these rule sets cannot obviously be manually made, and they are very dynamic, which is why we use a model here. But how we go about doing this is we look at, let's say, the transaction history of the customer, right? What is their median transaction value, right? How much do you spend per transaction, essentially? And what is the total amount, let's say, that you spent in the last 3 months, in the last 1 year, in the last 5 years, depending on where the e-commerce site is. What are the or number of items purchased per transaction? Do you buy at least 3 items when you make a purchase? So this again varies from platform to platform. So if you're buying food on Zomato, you are likely to buy at least 2 items to 3 items per purchase, let's say, right? And so that varies based on the price of the product and the category. But within a particular business, it has a fixed distribution, right? And so we can utilize that in identifying if someone purchases 3 products on their per transaction, they are very likely to purchase something new, right? That's the kind of insight we're looking for. So that's one. The next one would be top brands purchased. Again, like I mentioned earlier, customers have a high affinity towards purchasing from brands that they trust and like. So what are the brands that you purchase? So if you purchase, there could be certain brands where, let's say, if you bought T-shirts from Roadster in the last 6 months, you are likely to buy another T-shirt at least in the next 6 months, even if it's not registered, right? So these are the kind of patterns we're looking for. And then discounts availed. So there are various other variables that can be taken here. Payment gateways, which phone you are using, when do you browse, or which day of the week do you browse. So there are various variables like that. Discounts, obviously, offers and discounts are very prevalent in e-commerce websites, and so you will find discounts pretty much everywhere, right? And so they obviously have an impact on the price. And so what e-commerce sites try to do is they try to sell you more, uh, or try to increase your basket so that they can make up for the lost margin on the discount that they give, right? And so uh, the discounts, obviously, if you are a high discount customer, I cannot sell you something at MRP. You are not interested, right? Similarly, if you don't like things that are on very high discount, I cannot sell you something at 70% off. You will not be interested, right? And so different discounts availed by different customers throughout their purchase history also have an impact on whether they're likely to purchase some new category or not, right? And so similarly, there's other data like demographic data. You have gender, city tier. I've only included some of the common ones, but yeah, these there are other demographic data also that could be available. And then browsing indicators. There are a bunch of variables that could be used. What do you often browse? What did you last browse? How many list pages? How many product pages do you end up on? How often did you browse and then end up on a product page? So the conversion there also has an impact. Favorites, which is similar to a wish list that you would see on Amazon or Flipkart. You are wish listing things that you like, or you are expressing intent of purchase in the future, right? And so these are some variables. There are various other variables also. For example, how much do you scroll, right? If you scroll too much beyond a certain point, then maybe you are less likely to purchase, versus the other extreme, where if you don't scroll enough, could be different reasons, right? Let's say you don't find the selection that you like there, right? And so you don't scroll enough, or you really like the selection, but you are having a hard time deciding what to buy. So different kinds of customers here exhibit different behaviors, right? And so yeah, I think browsing, there's a lot of data in browsing indicators that can be used, because that's primarily what you essentially did at the store, right? That's what that data is. So we basically, these are some of the data sets we use. There's various others also, but yeah, I think one very standard way of going about solving this problem is, let's say I have customer, uh, I have all of these metrics available for a particular customer. I also have a variable stating whether they ended up making a purchase in your new category. So let's say as we discussed earlier, let's say we are Swiggy starting consumer electronics, right? And so how likely are you to buy consumer electronics, right? The way we go about doing that is we look at customers who've made a purchase in electronics versus those who haven't, right? So we have two samples of customers, ones who have bought and ones who haven't. And then we take all of this data for all of those customers. And then we have a 1-0 column indicating, okay, these are the customers who did make a purchase in electronics, and these are the ones who did. So based on the difference in their patterns, we are trying to find which are the customers who are likely to purchase, right? And so what are the characteristics, what are the behavior exhibited by a customer who makes a consumer electronic purchase on your platform? So all of this data basically goes into a classification model. Now, a lot of you might be already familiar with classification models, but yeah, I think uh, you would the process here would be very standard. You would first go about doing an EDA. So how would you do an EDA? So one example is, if you look at the median transaction value here, what are we trying to see here? What is the median transaction value of a customer who has purchased electronics versus someone who hasn't, right? And so it would be something like the box plots that is shown here, right? So if you see that the average transaction value is higher for a customer who's purchased electronics, you know that, okay, people who spend more maybe are more likely to buy consumer electronics, right? And so this could be done for all of these variables, all of the variables that here. it each variable that you include in your model helps solve a particular hypothesis. So, for example, discounts availed, right? The hypothesis it helps you solve is, uh, does high discount lead to a consumer electronic purchase? That's the simple hypothesis that you could solve using your EDA here. So post that, I think there are various different classification methods. I don't want to go into too much detail, but yeah, I think some of them are listed here, like decision tree, random forest, so on. XGBoost. These days you have more complex algorithms like LightGBM, CatBoost, etc., which are fairly robust classification methods, right? And so what we try and understand again through the confusion matrix or the ROC and AUC here, and various other metrics also, is essentially how well can you separate out, or how well can you predict what are the factors that impact a customer's purchase, right? And so one example would be, if you look here, this is essentially the different groups of customers that we've separated out based on, are they highly likely to buy, not likely to buy, or they have a medium likelihood of buying, right? And so if you find a cohort of customers, for example, the orange ones here, let's say, customers, let's say here, buy a lot of consumer electronics, and they are very similar to the green cluster of customers who don't buy electronics as much, but they are very different from customers, blue customers here, who also have never purchased consumer electronics. So these customers I would not bother targeting right away, right? These are the customers who are similar and are most likely to purchase because they exhibit similar characteristics to this one, right? So it's a different way of doing segmentation, but why we use it is to identify demand that has not already been fulfilled. If you are a customer who buys consumer electronics, you buy headphones, you buy let's say AirPods or phones, for example, but you do buy them on Flipkart, right? How do I get them? How do I get them to buy it on Myntra, right? I would have to look at other characteristics and other purchases that they've made. So this basically helps. This process is something that can help you going about solving that. Right? So I think that's what I primarily had. Yeah, I think those are some of the use cases. We can obviously discuss others also, but yeah, I think we can. If there are any questions, I've been going on for a while, so yeah, if there are any questions, I can take them. Hi, Siddharth, can you hear me?
Yeah, Anurag, yeah.
Yeah. Sorry. Yeah, I think that's what I had for today. Yeah.
Okay, okay, okay.
And if there are any questions, I could take them up. Right.
Mhm. So thanks a lot, Anurag. That was a great session, and I hope all our attendees found it really helpful. So, like just before the Q&A, before we
Mhm.
proceed to the Q&A, I would like to request the attendees to please fill in the poll about feedback, as it helps us to conduct most of the sessions. There will be a poll on your screen, like, mm, yeah, it's live. You can just fill it, and then we'll take the questions. Yeah, meanwhile, Anurag, you can start taking the questions, I guess.
Yeah. So I think if I saw a few people who had questions, if there's, should I just check them from the Q&A? Okay. What is so Abu Rehan asks, what is transaction in this case? Yes. So a transaction is basically a purchase that you make on an e-commerce site. So let's say you went to Amazon, and let's say I bought a guitar and I bought drums, right? And so now I made a purchase. These are the two things that I purchased. They belong to certain brands. So all of this information, how much did you pay for them, for each of these items, which brands they belong to, when did I buy them? All of this is basically transaction data, right? So a transaction is obviously you buying something, but what we primarily focus on is all of the data that can be extracted from a particular transaction. Aditi, I think, yeah, can you explain confidence and lift again? Sure. So, yeah, I think, Aditi, I think confidence here is how often do X and Y occur together? So let's say X and Y is our bread and butter. Okay. Now, the reason why I'm looking at these rule sets is I want to combine certain products together. I want to bundle them together, right? So let's say I'm the rule that I'm testing for is what is the impact that bread has on the sales of butter, right? And so the confidence here would be how often do bread and butter occur together divided by how often does only bread occur, right? And so that's what the confidence would be. The reason why we're seeing is because if bread occurs in every transaction, right, it does not have an impact on something else also being purchased. Or for example, if you buy butter very often, or if you buy eggs very often independently also, so you cannot attribute the sales of those eggs to the bread that you purchased along with it. And so that's why we take this confidence measure. And so I think support and confidence would be enough. Lift is just a derived metric from support and confidence. So that's the final metric that you would use to rank. So for example, if you see here, root vegetables, right? For root vegetables, there are three use cases, right? Root vegetables with beef, with tropical fruit and other vegetables, and with citrus fruit, right? So there are three cases. All three have different lifts. So this has 3.29, this has 3.14 and 3.04, right? And so whenever someone selects root vegetables, they should be recommended citrus fruit and other vegetables, right? Because it has the highest lift. So that's what we use it for, right? For each of these items in your total basket, what are the best products that go along with it, right? And so the 3.29 here essentially means you again you are 3.29 times more likely to buy these together than just root vegetables itself. So that's what it is. I'll move on to the next one. Yeah. How do we take into, so Abhishek is asking, how do we take into account the incentives to buying a bundle while training the data? Okay, so yeah, Abhishek, I think uh, we don't, so these are two different things, right? So the incentives are different from how you are bundling. What we are focusing here on is how do you bundle different brands together or different items that can be sold together. For example, the most basic example would be, let's say, a t-shirt and a jeans, or a shirt and a pant, let's say, right? You can intuitively bundle them together, but incentives are different. So when you create intuitive bundles, they may or may not work, right? So you are spending more, but you by making changes on your platform, but it does not give you a good enough ROI. So how we go about doing this is for all the customers, and I would probably go back to the first slide. Yeah. So for each customer, we map them to a particular basket, right? There would be some set of customers who we leave out. Let's say 10 to 20% of the customers we leave out as a control set, and we don't show them anything from here, right? They see what's already live on the platform. One example is, let's say, during, let's say, if there's a sale on Amazon, right? And um, you are seeing a particular recommendation of, hey, buy, let's say, uh, let's say buy a workwear or formal wear from XYZ brands, right? That is not something that every customer is seeing. Only certain cohorts are seeing, right? And so we will find a cohort similar to yours who have not seen this and are seeing what's generally live on the platform. And we just do a test and control. Yeah. Yeah. And so we just do a test and control to see what is the lift that has occurred in your campaign because of bundling these brands together, right? And so if certain bundles may not do well, right? So for example, here PQRST is just 5 different brand bundles, right? So if Basket Q, for example, had a bunch of customers where these customers actually ended up purchasing, let's say, lesser than the control customers who were not shown these bundles, then this is not a good basket. So we evaluate how these baskets are performing and through the lift in the campaign. Right? So yeah, I think that's one. Okay.
Yeah.
can I use a priori algorithms to find out frequent patterns? That's the main use case. So it's not frequent exactly. Frequent would be based on how often they occur together. But as I explained earlier, there are problems with frequently occurring patterns also because of the individual occurrences, and so that's why a priori is a alternative. Yeah, it is. No, I'll. You can check the formula. Lift is just a derived metric. We primarily focus on support. Could you recommend frequently brought together. Okay, so uh, there are multiple algorithms here. Again, you can use collaborative filtering to find out which brands to recommend or which items to recommend to a particular customer. That's very common, and then you can aggregate them together into different baskets of items, right? So that's similar to what you see on Amazon. People also purchased and or often bought together is the section in Amazon where you would see these frequently bought together cases. They use these kind of algorithms. What's the ML algo used? Collaborative filtering is the algo used. How do we deal with the problem of data sharing? So data sharing is not really a problem. We have GDPR rules, and there are all kinds of rules for data sharing. So it depends from company to company. If you're an Indian company or a US company, it varies. But yeah, I think the government already has data sharing practices in place. That's fine. How to code cluster. I can take any further sessions, but I primarily work on R. But yeah, I can take sessions with code also. Majority of customers buy one category of items from Myntra and another products from other platforms. How can you analyze them on their preferences? Yes, so yeah, here. So we don't know if they make purchases on other platforms. SB. We don't know if they make or don't make purchases from other platforms. We do know that there is a share of wallet customers have. So if you spend, let's say, mm, let's say 5,000 on every footwear purchase you make, you can spend, let's say, 10% or 20% of that on a belt that you might purchase along with it, right? So the customer always has some share of wallet for related items that they're purchasing from elsewhere. So what we try and see is we look at the people who actually purchase, in this case from Myntra, and we look at the people who haven't. And if they are very similar customers, it's similar to a like analysis. So if they're very similar customers, we are going to recommend them also products that you already purchased. So propensity is like binary classification, like buy or not. Yes. So it's not necessarily binary. It depends on your use case. I've just put a binary classification model because it's simple to explain, but different there could be different labels for class. So it could be a multi-level classification. So, can we use a priori for building upselling and cross-selling models? Yes. I think the one of the most common use cases for upselling and cross-selling is a priori. Yeah. So that's something we that's the primary use case for that. Yes. Is a hands-on session. Sure. If yeah, there's a chance. Could you explain one of the models, ML models used practically, how it worked with the output? I can do that in a different session, but yeah, there are some. The reason why I've kept some of the details vague is because I cannot share some details from class. Uh, I think yeah, no, I think that's if I can
Yeah.
use for other uses. I think that's it. Yeah.
Okay.
Yeah.
Yeah. So thanks a lot, Anurag, on behalf of Analytics Vidhya.
Thank you for inviting me.
And yeah, and I'm sure our audience found it insightful and helpful. Hopefully, we can conduct more such sessions with you in the future.
Sure, no problem. I'm
Yeah.
always open.
So,
Thank you.
guys, we have already mentioned Anurag's LinkedIn profile in the chat section, so you people can connect to him over there. And we will be back with another session of data on tomorrow, 15th of September. So you guys can register for that too. And thank you so much, Anurag, for your time. And the session was really helpful and it was really great.
Thank you for
I
inviting
personally
me.
enjoyed it a lot. Yeah, it
Thank
was
you.
very informative. Yeah. So thank you guys. Take care and
Thank you
bye.
everyone. Thank you everyone for joining. Yeah, really appreciate it.